This diagram represents the complete system where we see the microcaster scheduler, which is controlling various tasks in the system at the application layer. Now we know that we've set the application task to a polling mode so that it can continuously monitor the amount of data which is being received. Now we saw previously the open call, which was used to pass the generic TTY layer to interface with the hardware specific layer to configure for the mode of operation that we wanted. When we made the open, the generic TTY layer also created for us an aligned buffer. Now this is modulo aligned, which means that its start address is an address which is divisible by the modulo length. For example, the address which we see here is suitable. The length of the buffer which we requested was 128 bytes, which is also a modulo length. Now the reason for this modulo is a restriction, you could say, in the DMA controller which is used in the KL series of parts. When we receive characters from the physical UART, it triggers a DMA operation. The DMA operation takes the received character from the input buffer and copies it into the receive buffer. It then increments its copy pointer, so the next carriage which arrives will be copied at the next location in the buffer. Obviously with time the buffer will become full. Now as long as we've declared correctly our modulo buffers, the DMA controller then does an automatic wraparound, which means that the following byte received will then be located at the start of the buffer again, and it continues. So we have a continuous operation which requires absolutely zero software support, where all of our received characters are being put into this circular buffer. Now the problem with this is that if we do not remove the data in time, it'll be overwritten. The second potential problem is the fact that our system at this layer has no idea directly of what happens here. There are no events to tell it that it needs to collect some data. That's the reason why we put it into this polling mode. So what happens is that when we're in the polling mode, we're using the read function to tell the TTY driver to check whether we have any data. This is the polling as we understand it. Not a polling of the received buffer. We've got no risk of overruns here. It's a polling of the amount of data in the reception circular buffer. Now there's a little risk of us having data overrun if we were to stop checking and reading. At some point in time, depending on the size of the buffer, depending on the speed of the reception that we're receiving, the buffer will overflow before we've cleared it. Now as long as we put adequate buffer size here, and we either poll continuously or check periodically at a rate which is adequate to allow us to read the data out before it gets overwritten, then we've also got a good solution. To finish, I'm going to take the binary which was also created when I built the project, and I'm going to copy it to a physical FRDM-KL27 board. And this is the terminal emulator which corresponds to it, and we can see here that we've got activity. So it's a verification that the software which we saw operating in the simulation does really run on the physical low power UART with DMA operation. And a final trial, I've connected this board to a debugger and I'm going to let it run. Now you can see that it's just started up again here. Now what I'm going to do is I'm going to set a hardware break, well, I'm going to freeze the processor so it's not running anymore. Now this is where it's going to get interesting. I'm going to type in some characters. Now don't forget, I'm going to type in 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the processor itself cannot react because it's being held by the debugger. So I'm going to do a single step in the debugger and watch this area here because it's going to be updated. This is looking at this software buffer. I just did a single step and you can see here the characters which I've typed. Now that is a proof that the DMA is transferring the received UART data, which I put in here, into this physical memory space without any CPU overhead at all. Now if I let it run, we can see here now that the echo feature in the application input worked because there was no loss of data due to the debugger being frozen. It was still being put into the buffer as normal by the DMA operation, so as soon as I allowed the system to start operating again, then it could take the data which was available and complete its processing. Many thanks for watching and good luck with your own developments based on MicroTasker and the KL27 or whichever other Kinetis part you choose.